Okay, so this is the last part of our run-through of Chapter 3 that we're going to do, and this is solving systems using graphing or algebra. So, depending on the directions, you could use either one here to solve a system, and we're talking about graphing, like I said, but also substitution and elimination. Now, you've done equations that have 3 letters. We're just doing ones that have 2, so those are quite a bit easier. So first, just a reminder of how to solve a system by graphing. So we have 2 equations right here. If I were going to do this by graphing, I of course can graph by hand, but you're going to get a better answer if you do it with the calculator. So first thing I would need to do is to solve each of those for y. So let's do the blue one here first. 3y is equal to 12 minus x. Divide everything by 3. Now, I have this written over here. This is the first one. Now I have it written a little bit different. I put the x in the front for some reason. You could also do y is equal to 4 minus x over 3. That would also be okay, but this way you don't have to worry about accidentally dividing the wrong thing. If we do the other one, let's see, I kind of ran out of space, so I'm going to write it over here to the side. So negative 2x plus 4y equals 9. Would be 4y is equal to 2x plus 9, and then divide everything by 4. You can see that there. Okay. So once you graph them, you're going to go to calculate and intersect. So calculate is second trace. Let me show you in case you've not done that before and you need help. So we go to y equals and clear anything that you've got in your y equals. And I'm going to just type this in exactly the way that I have it here on my paper. And of course we want it in a parenthesis so that we're dividing everything by these numbers, not just the last thing. Now, a couple things you want to make sure up at the top here that the word plot is not lit up, because otherwise it may not graph for you correctly. If for some reason your calculator won't let you graph 2 equations at the same time, let me know. Sometimes there's another program that's running in the background that causes you to not be able to do that. So we hit graph. Now, once these graph, if you've done anything with your calculator that's kind of messed up the window, I'll remind you how to fix that. Okay, window, okay, mine's negative 10 to 10 by 1. You can either retype that in, or you can go to Zoom and go to Zoom Standard, and that puts you back to normal automatically. That's kind of a good one to remember. Okay. Now, once they graph, you could hit the trace button, but the thing about the trace button is it's not necessarily going to stop where you want it to stop. So we're going to hit second, like I said, and calculate, or trace, and we're going to go to number 5. Now this one's really easy to use. Go to where they cross, and it's going to ask you 3 questions. Okay, where's your first graph? Well, I'm actually on both of them at the same time. So hit enter again, and then now where do you think they cross? Well, if you go to where they cross to begin with, then all you have to do is hit enter 3 times in a row. Now, because there's no decimals after the 2.1 and after the 0.3, that's an exact value, because it's going to give you a whole bunch of decimals otherwise. So my answer is 2.1 and 3.3. If you do have a bunch of decimals, then of course just round them off, use your 3 sig figs. Okay. So my solution up here at the top, 2.1 and 3.3. Okay. All right, now what if we need to use algebra? Now, why would you need to use algebra? The directions say to use algebra. Or maybe they want an exact answer. Graphing is not always going to give you an exact answer, but algebra will always give you an exact answer. Okay, so substitution is the first method here. I'm not going to make you do it one way or the other, so you can really do it whichever way you prefer, but I want you to practice on your homework doing it however I've asked you to do it. So substitution, you're looking for ideally an x or a y that is already kind of isolated, at least that there's only a 1 in front of it. So right here I can see that I've got just a single x. So I'm going to solve that equation for x. I could have solved it for y, but think about how yucky that would be, and same thing down here. Now, if, let's say that in this case I was solving for x in this bottom one here, and let's say that the 9 was actually an 8. I could solve for x in that equation because I could divide everything by a negative 2. It's just easier when you don't have to divide anything. Okay. So what I am going to do, though, is I'm going to get that x by itself. So that's going to be x is equal to 12 minus 3y, or negative 3y plus 12. That's up to you. And now I'm going to plug it into the other equation. Now you always have to substitute into a different equation. You can't plug it back into the one that you had. So that's going to be -2, and then in parentheses here, actually let's do this in a different color. Okay, so I'm going to put that in here in red. So that's going to be 12 minus 3y plus 4y is equal to 9. So now distribute. -24 plus 6y plus 4y is equal to 9. 10y is equal to, actually I didn't write that down. 24 plus 9, let's see, that would be 24, 34, 33. And then y is equal to 3.3. Now that's the hard part. You've solved for the y. Now you got to go back and solve for the x. So I come back here, take either one of these equations. I'm using this top one here because it's easier to find x because I'm not going to have to divide by anything. So I plug my 3.3 in here for my y, and I solve, and I get 2.1. So my answer is 2.1, 3.3. Notice that's the same thing as what we just had because it's the same set of equations. So in this case, we get the same answer both ways because my answer in the first example was an exact value. Now, one thing to be careful about when you write your final answer, make sure that you write it x comma y. I found the y first, so sometimes students are prone to write the y value first in their point even though it should be the x. Now, again, just to show you that it doesn't matter, let's do the same equation again, but now let's use elimination. Now, elimination, you want to eliminate one of your letters, and we're going to do that by adding our two equations. You really don't want to use subtraction because it's harder to subtract, so there's a chance you make a mistake in your arithmetic. Adding's a lot easier. So when we add, we want to add opposites. So looking at these right now, it'd be very easy to change that 2 into a or to change that x into a 2x, and I can do that by multiplying. So I'm going to take this top equation here times 2. 2x plus 6y is equal to 24. Make sure you take everything times 2. And then the bottom equation I'm going to leave the same. Because now if I add, my x's cancel out. I end up with a 10y is equal to 33, and hey, I get the same thing again. And again, go back and find our x. Answer 2.1, 3.3. Personally, I like elimination better than substitution. I totally understand how to do substitution, but it's way easier, in my opinion, to use elimination. All right, one more example here, and then some story problems. So sometimes with elimination, you have to end up multiplying both equations times something. Think about it like getting common denominators. So, sorry, that should be back on the last part there. Here's my system of equations. Right now, the m's will not cancel out, the n's will not cancel out. So it's going to be just as easy or just as difficult to get rid of either letter. So I'm going to get rid of the m's just because. So thinking about a 2 and a 3, 6 would be a good number, like for dealing with fractions, trying to get a common denominator. So let's make them both be 6's. To do that, I'm going to take the top equation times 3. Let me actually write that over here. I'm going to take the top equation times 3, which will make that be a 6m. And then I'm going to take the bottom equation times -2. I need one of them to be negative. You decide which one you want to be negative. 6m plus 12n is equal to -12. -6m minus 10n is equal to 6. My m's cancel out. 2n is equal to -6. N is equal to -3. Now, once you find that first letter, don't forget to go back and plug in the other one. That's the easy part. Don't do the hard part, not the easy part. When you write your solution here, and I don't have x's and y's, it's alphabetical. So m comes before n, so 4, -3. Now, this next little part here is just FYI. When you graph a system, if there are 2 intersecting lines, you have one answer. If you only see one line when you graph 2, then probably graphing on top of each other, or one is so much bigger that you can't see it in the same window. If they are the same line, they're on top of each other, then you're said to have infinite solutions. And then if they're parallel lines, you can tell that they're parallel, then that would be no solution. This is what you would get if you were solving it algebraically. In the first case here, all of your letters cancel out and you end up with 0 equals 0 or 5 equals 5 or something like that. That means infinite. Here, all your letters cancel out and you end up with something like 0 equals 5. 0 doesn't equal 5, so that's no solution. So we got a couple story problems here, actually just 2 story problems. So with story problems in general, you're looking for totals, and you're going to write an equation for each total. If at all possible, use variables that represent the information in your problem. So if you're dealing with dogs and cats, use D and C, rather than having to constantly remember what's X and what's Y. Okay, so we have a hardware store sells 3-liter paint cans for 15 pounds. That kind of curly looking L there is the symbol for pounds. And 5-liter paint cans for 20 pounds. Now also, in case you see this and you're thinking, man, she can't spell the word liter, that's the more international version of this word. So every once in a while, if you see a word and you think, man, that looks weird, that's probably the international way of doing it. Okay, so anyways, the 3-liter paint cans are 15 and the 5 are 20. In one day, the store sells 71 liters of paint worth a total of 320 pounds. How many paint cans did the store sell? Now, this is a little bit more difficult because of the fact that it doesn't say that they're selling 71 cans of paint. They're selling 71 liters of paint. So however many cans of the 3 liters and of the 5 liters, they're going to multiply those cans times how many liters there are and then add them all up. So we got to keep that in mind when we're at our equation. Now, first of all, the money equation is easy. I'm going to make T be 3-liter paint cans, since 3 starts with a T, and F be for 5-liter paint cans. So my money equation is going to look like this. It's 15 pounds for each 3-liter paint can, and it's 20 pounds for each 5-liter paint can, and that equals $320. Now my liter equation, I'm going to take 3 times how many 3 liters I have, and 5 times how many 5 liters I have, and that's going to equal 71 liters. Okay. And now we solve, and you solve this however you want to solve it. I'm going to solve it using elimination because, like I said, I like that one better. I'm going to take the liter equation times -5 and then add the money equation to it. So 15T plus 20F is equal to 320. Negative 15T minus 25F is equal to 320. That's not right. I wrote mine upside down from before, sorry. Try this again. Negative 355. Okay, so I'm adding these two together. Now, the way that I have that written there in the print, I meant to write them down upside down from each other. It makes absolutely no difference, though. I went ahead and wrote the money equation still on top and my liter equation still on the bottom, which is fine. We add now, the T's cancel out, negative 5F, which might kind of freak you out, but I end up with a negative over here too, so it's all good. So I end up with F is 7. So I need to know how many paint cans the store sells. So that's going to be 7 for this, and then when I plug that back in, I end up with 12 of the 3-liter cans. Now I'm realizing here that the answer just says how many paint cans, so that's a little bit vague. I think you could say 7 5-liter and 12 3-liter, or you could say 19 cans, because that is how many that they sold. Honestly, I would maybe just cover your bases and do both. So you can say 7 3-liters and, 7 5-liters and 12 3-liters and then 19 total. Okay. All right. And, sorry, that should be on the next page there. Okay. So I have 2 young trees, 6 feet and 9 feet tall, are planted in a garden. The smaller tree grows at a rate of 2 feet per year, and the taller grows at a rate of 1.5 feet per year. We're going to use a system of equations to find what year the smaller tree first passes the taller tree in height. Okay, so this one's just a little bit different because I don't have totals. I don't know how tall the tree is after so many years or anything like that. So I'm just going to write equations for the trees, and then I'll set them equal to find out when they're the same height, and then I can go from there to figure out when they would be taller. So my smaller tree starts off being 6 feet tall, and then every year we're adding more feet. So I'm going to say 6 feet. Actually, I'm not going to put the word feet there. We're starting off with 6 feet, and every year I'm going to add 2 feet to that. So my equation is going to be 6 plus 2f. I don't need to rewrite that. Oh, I know. On my paper I had written the word feet. So that's going to equal 6 plus 2f. Okay? 9 plus 1.5 feet per year. 9 plus 1.5f. So, set them equal. 6 plus 2f is equal to 9 plus 1.5f. Okay, I'm not going to go through how to solve that. You're good with that. We end up with f is 6. So, find what year the smaller tree first passes the taller tree. So, in 6 years, they're the same. But sometime during that 6th year, it's going to be taller. So you have to be kind of careful sometimes about how you give your answer there. So I would maybe give a paragraph with your answer. Say at the beginning of the 6th year they will be the same. During that 6th year, the smaller will surpass the larger tree. Okay. All right, so you've got a worksheet for this one. Solutions are on my website, and that's it. So we'll have review worksheets next week over whatever chapter we were doing, the trig chapter, and then chapter 6, Chapter 6 with the trig and the geometry, and then this other additional stuff here on geometry.